In this lesson, you'll use a sensor to trigger a notification. So now that you've covered the basics, and by the basics I mean you configured the Arduino to communicate with your PC using Fermata and PyFermata. You know how to address digital and analog inputs and outputs and know some of the basics about electronics. So what are some other uses for adding an Arduino to a PC? I'm going to show you a couple examples. One is going to use a digital sensor to trigger a notification, a pop-up on your computer screen, kind of an alert. The other is going to be generating an email based upon a sensor event. So what are you going to use to display this notification in Python? You'll use tkinter, which is part of the standard Python library. In fact, it's the standard Python GUI toolkit, graphical user interface. Using tkinter, you'll show a message box when you press a button. And one nice thing about this circuit is it's going to be the same circuit you've used in the digital input example. This lesson will only scratch the surface of what tkinter can do. So I'll include links for more information on the web and an article on Real Python. So here's that circuit again. I won't spend too much time on this, but again, the 5 volts comes out of the power section, goes into the switch and into input 10, and it still has that pull down circuit. On the breadboard, same layout as before. If you need to review it, you can find pictures of both the circuit and the breadboard layout below this lesson, but you can go back to lesson 6 to walk through it step by step. This program is going to look similar to the one that was used for the digital input example, but there's a few different changes. I'm going to go ahead and create a new file and call it notification.py. Okay. So you might remember in switch.py, you imported PyFermata, imported time, set up your board, and so forth. In fact, I'm going to just copy a lot of the stuff that's in there and put that into notification, paste. Okay. Along with PyFermata and time, you need to import the tkinter package, and from tkinter, you're going to import the message box. You need to set up a little bit about tkinter. So root tkinter, you're going to set up tk. Here you're setting up the tkinter main window. And then right after that on line 7, you're withdrawing that main window because you only want to see the message box. Again, you can find more tkinter information below this lesson. So then you're going to set up your board on line 9. And here you're still setting up the util for the board and iterating on it to, again, look for that switch. It still uses the same board input, and it's still going to use the flashing LED there when the button is pressed. So time to look at the while loop. This is where a lot of the change is going to happen. Still going to look for the digital input read, but this time if it's true, not only are you going to write to the LED, so here's where you're going to use message box that you imported from tkinter and show info in the message box. You have a title of the box and then a string message. So the title will be kind of a generic notification. And then the next thing is the button was pressed. The loop will pause there, waiting for the user to press OK on the message box, and that'll keep the LED on. Then the root update will erase the message box. Don't need an else. You can tell the LED to turn off. Again, it's going to keep looping around looking for that, and then you still want that sleep there so it doesn't tie up your computer too much. Go ahead and save. And down here, Python, you can run notification.py. Yeah, I did. I missed something big. Got to activate my environment, so PyFermata was not available. So try that again. Python notification.py. Here it is running. And I'm going to press the switch. Okay, there it is, the tkinter box showing the notification that the button was pressed. And it happened again. And so forth. Great. Nice. I'm going to quit. Control-C, breaking out of that, interrupting it. For this next code example, you're going to send an email. Now, setting up email and sending And configuring that in Python is an article of itself. In fact, if you really want to learn much more about this, or you're having some troubleshooting issues, I'm not going to go too deep into it. I just want to show you that it's a possibility, but there is a real Python article on this that goes much more in depth into it and talks about how to troubleshoot a lot of the issues you may have. The code you'll use is really similar to that article, minus the bit of using the Arduino. And there's an accompanying real Python course you can watch that goes over all of the concepts also. So this will be a great resource for you to learn more about setting up emails if you have deeper questions or have trouble configuring it. For the example configuration that I'm going to show you in this one, I'm going to use a free Gmail account that I've already set up. And I've already configured the allow less secure apps options. I'm going to include links to all of this information below this lesson. Another issue that I had, since I've recently reconfigured my computer and installed Python from scratch, on a Mac, it does not install the certificates that are used for sending and receiving email through Python. That's a separate step that you have to install certificates from the location where Python is installed. There's a script inside there you have to run. All right, let me have you try it out. To set up the credentials for the email addresses that I'm going to use, I'm going to show you a technique where you could use a module for that information, that you could keep the email accounts and password separate from your application if you'd like. There are multiple ways to approach this. So you're going to create a new file, creds.py. Into this file, you'll create variables for sender email, which will be the text string of the email account you're coming from, the receiver email address, and then the password for the sender email account. Now I've blocked these out, but you would put your credentials in there for the accounts that you've created. Then for the mail script that you're going to create, just create a new script. I'll call it mail notify.py. Okay, I'm going to copy most of the notification script into mail notify. Close that one. The next step is to import the credentials, but also remove the imports for tkinter. From creds, import sender email, receiver email, and password. Great. So that stuff will now be imported. You're going to use the SMTP library, SMTP lib, and you need to import SSL. Okay, so that stuff's been imported. You're not using tkinter, so remove those lines. So here, you're going to define a function called send email. It's going to have a port. The port for SSL is 465. The SMTP server will be using Gmail, so it's smtp.gmail.com. And then you need a message. Here, your message will be subject, Arduino notification. You're going to put a line break there. The switch was turned on. You need to create a context. Context will be an SSL, and you're going to create a default context. That's the method you'll use. Then you're going to use a with block here for containing this all here. Context manager, if you will, SMTP lib, SMTP SSL. Okay, here you're using SMTP server, using the port you set up a moment ago, and then context will be equal to the context. So with SMTP lib SMTP SSL as the server with all those parameters, you're going to say print out this that you're sending currently an email. You need to log into that server. That's used with the sender email that you imported in and its password. And then server send mail. First, you got to say the sender email, the receiver email, and then attached to that is the message. So I'm not going too deep into all this. Again, you can learn much more about sending emails in these other tutorials. Still got your board set up here. Looks good. Got your iterator. So it's looking for the button presses. Digital input still coming in D10. This time you don't need this LED as an indicator. So during your true loop down here, you're going to read for that input. If it is true, not going to write the LED. In fact, you're just going to go ahead and send an email. Call your function you set up a moment ago. Okay, that all looks good. go ahead and connect to the Arduino. So Python mail modify.py. And if I press the switch, it says sending the email. And pretty quickly, here in my mail program, you can see 2 messages received. I accidentally pressed it twice, but you see Arduino notification there. Looks good. All right. It looks like you're ready for the conclusion and a course review. That's up next. This lesson is the conclusion and course review. Let me say congratulations on completing the course. And throughout our time together, you learned how to develop applications with the Arduino and Python. You learned how to use the Fermata protocol, and along with it, a little bit about the library PyFermata. You learned how to control analog and digital inputs and outputs on the Arduino, and how to integrate sensors with higher-level Python applications. Let's do a quick review through the table of contents of what you learned. It started off with an introduction and course overview. Then you moved into the Arduino platform. You installed the Arduino IDE and learned a little bit about resistors and using a breadboard. Then you set up your first program using the Arduino, sort of a hello world, and connected your Arduino to your PC and set up its ports. Next, you started to connect external components to your Arduino board. Then you set up the Arduino and the Fermata protocol to be able to have it talk to Python and redid that hello world program. Next up, you were reading digital inputs and using a switch. After that, you were reading analog inputs and using the PWM outputs that would emulate the analog outputs. Then you got to build something that was a bit more of a real-world application of using a sensor to trigger a notification or send an email. And then there's this conclusion and course review. I'd like to leave you with some additional areas for you to explore. I'll include links with much more information below this lesson. Up first is to explore REST APIs. These are widely used to integrate different applications. You could use REST with Arduino to build APIs that get information from sensors and send commands to actuators. To learn about REST APIs, check out the Python REST APIs with Flask, Connection, and SQL Alchemy. You could continue off what you touched on here with GUIs. There's a tutorial where you use tkinter to build a graphical application. However, there are other graphical libraries for desktop applications. Threading. The infinite while loop that you use throughout this tutorial is a very common feature of Arduino applications. However, using a thread to run a main loop will allow you to execute other tasks concurrently. Check out an intro to threading in Python. Face detection. It's common for Internet of Things apps to integrate machine learning and computer vision algorithms. With these, you could build an alarm that triggers a notification when it detects faces on a camera, for example. To learn more about facial recognition systems, check out traditional face detection with Python. And then there's a few other ways that you could be using Python with microcontrollers besides Fermata and Arduino. One is PySerial. Arduino Uno cannot run Python directly, as you've learned, but you could design your own Arduino sketch and use PySerial to establish a serial connection. Then you can control Arduino and Python using your own protocol. If you're interested in running Python directly on a microcontroller, check out the MicroPython project. It provides an efficient implementation of Python to be executed on some microcontrollers, such as the ESP8266 and the ESP32. SBCs. Those are single board computers, such as the Raspberry Pi, that you can run Python on. SBCs are complete Arduino-sized computers that can run a Linux-based operating system, allowing you to use vanilla Python. As most SBCs provide general-purpose inputs and output pins, you can use it to replace an Arduino in most applications. I want to thank you again for watching, and make sure that you practice with what you've learned here.